Okay, what's happening? What's wrong? So here, that's messed up today. Zooming or not zooming? Here's the thing. Okay, so do you have any questions that you want to go over first from the review packet? Anything that either we went over last time but you don't understand, or that we haven't gone over yet? No? All right, so we left off with, I don't know if we did 41 and 42 in second period, but I don't know if we did in first period. This one, in order to get rid of the radical in the denominator, which is called rationalizing the denominator, you have to multiply by the conjugate of whatever is here. So if whatever is here is addition, then change it to subtraction, and that's the conjugate. This is something we're supposed to have covered this year, but I don't think we did. So I'm actually going to remove this question from the final exam. And I did get an answer from Coach Merrill. There will be 30 of these questions on your final exam. They'll be randomly chosen by Canvas when you take your test. So out of the 120 or so that are on here, you'll get 30 of them for your exam. But so if we do this, but just to go ahead and show you, because you will see it, you'll need it, you'll do it next year. So multiplying by the conjugate, I changed this to a minus sign. When you do that, if you remember, if you think about difference of squares, when you have difference of squares, you have a plus and a minus, and the middle term always goes away, like x squared minus 9. That's x minus 3 times x plus 3. And it's a formula difference of squares that you need to know like forever, because you're going to use it every year from now on. So that's the principle that we're using here, that by making this a negative, we're going to get rid of the middle term. And when we get rid of the middle term, the radical goes away. You know that anytime you have an expression, as long as what you multiply is effectively the value of 1, you can multiply by anything. So if we multiply the numerator and the denominator by 6 minus the square root of 7, then this is equal to 1, but it's going to change the format of this. It's not going to change its value at all. If you put this in the calculator correctly, and you put my final answer in the calculator correctly, you will get exactly the same decimal number. It's equivalent, but it reads nicely. Now in pre-cal, we do a little bit of this so that you know how to do it, especially the conjugates, but the College Board has decided that rationalizing the denominator is an extra step. It's an extra place where you can make a mistake, and it's an extra thing for them to have to grade. So they no longer require that denominators be rationalized. So you can leave radicals in the denominator in AP Calculus, and it doesn't count off. It's not wrong. So they've sort of modernized. But our textbook hasn't, and our semester exams haven't, and other things. You still might see it on an SAT question where you have to rationalize the denominator. So we still cover it so that you know how to do it. So if I do FOIL with this, I get the 6 times 6 is 36. Then I get the 6 times the plus square root of 7 and the 6 times the minus square root of 7. So when I add those together, that's 0. They go away. And then I add the plus square root of 7 times the negative square root of 7 gives me minus 7. So then the denominator ends up being 29, and the numerator is 8, which is here from this side, times 6 minus the square root of 7. Now your answer choices might be, they might distribute that. It might say 48 minus 8 square root of 7. if this had been something that would reduce, if these had both been even or divisible by 4 or something, we would have done that. But otherwise, this is fine as your answer. And then this question is making sure that you understand how to go from the radical form to the rational exponents. So you remember that you have m root of x to the n. This is the same thing as 3 equals means they're identical. It's the same thing as x to the n divided by m, your fraction. So your root or the index is always the denominator in the fraction. So I have this m to the 20, and then the denominator is 5. So m to the 20 divided by 5, w to the 5 divided by 5. So 20 divided by 5 is 4, and 5 divided by 5 is 1. So this is your answer. So this question is just making sure that you understand and that you remember this. This is also something you need for the next several years to change the format from a radical to a rational exponent. Questions? So then this part is making sure that you remember that the roots have to match. If the roots match, then you can add and subtract them. If the index or the roots don't match, then you can't do anything with it. You just have to leave it. This one is in your rational form. So we know that this, and this is only on the n. Notice it's not in parentheses. So what we have here is 7 fifth root of n squared plus 2 fifth root of n squared. So we have 7 of these things plus 2 of these things. So that gives us 9 of these things. Likewise, you could have changed the first one to a rational exponent, as long as you remember that you can only add them if the exponents match. Next year is pretty heavy in needing to know your exponent properties, your log properties, and factoring. If you can do all of those things well, the new stuff that we add to it in pre-cal won't give you any trouble. But if you're struggling still with your exponent rules and what you can and cannot do, with your log properties and what you can and cannot do, or if you're having trouble, if you struggle with factoring. Factoring not only is part of everything we do all year, we expand it to things that we didn't cover this year, and then we apply it to other things. So when we get into trigonometry, you will have expressions that are made up of sines and cosines that you have to factor. The rules are the same, it's just not a variable. It'll be like sine squared x plus cosine squared x, and you have to deal with that instead of x squared plus y squared. This one is a plug it in the calculator or plug in the number. They're giving you the value of t, which is 5 years, and figure out what the answer is. This one actually says graph it and then tell the domain and range. Now, at some point during pre-cal next year, you need to get to the point where you'll know what this domain and range is, because you know it's been moved. You know it's the square root function, which the square root function looks like this. Then you know it's been moved left 5. So this has been moved over here. And then it's been vertically compressed by a 4th. So it's going to be a 4th as tall as it was before. But in terms of domain and range, if you know that's been moved left, you know from the original, you don't have square roots of negative numbers. So it couldn't have been left of 0. So it won't be left any farther left than 5. So your domain is going to be all the x's greater than or equal to -5. And the fact that we've shrunk it, we made it shorter, flatter, does not mean that it doesn't continue to grow in the y direction. It just takes it a lot longer to get to infinity than it did before, but it's still going to go to infinity. So your range is still going to be from greater than or equal to 0 or from 0 to infinity. All right, all of this section about the transformations, if we have a transformation g of x, a f of b, in everything we do, and since we didn't get to create the foldable this year, usually we create a foldable in Algebra 2 and you keep it and use it during pre-cal. So we'll create that foldable next year. But this out in front and out at the end, so not inside the function, both of these things are vertical. This one is your vertical stretch or compression. And you're going to see some words that say shrink, but that is a terrible word. So we're going to stick to the actual math vocabulary. And reflection. So reflect across X axis. Vertical reflection is across X. It's up and down. So it's across the X axis. This one is the same things, but horizontal. So it's horizontal, stretch or compression, and then a reflection. It's going to reflect across the Y axis. Because it's horizontal, it's left and right. So that takes you across the Y axis. H is left, right, but opposite to the sign that you see. And K is up, down. So you need to get this in your head and just keep it there, this general form. It doesn't matter what this function is, if it's a quadratic or an absolute value or an exponential or a polynomial or a trig function. This pattern is the same for all functions, no matter what the parent function is. This pattern is the same, and these values do the same. When we get to trig, we call the H and the K something different because it's a phase shift. You don't move a trig function to a new place on the graph like the same way you do other parent functions, but it's still the same pattern. And we stick to this for this year, for next year, and for calculus. Then solving, just follow your rules. These are the same things you learned in Algebra 1. So I've got a square root, so I have to square both sides. So then I get 7x minus 6 equals 64. And then you just finish with your normal algebra stuff. On this one, when you square this side, you have to remember to square the whole thing. And this is not x squared minus 100. You're squaring the whole thing. This is x minus 10 times x minus 10. So you're going to have a middle term. So you're going to have x squared minus 20x plus 100, not just x squared minus or plus 100. And then that's equal to your 32x. I don't know why they call me during class. Hello, it's Ms. Turner. I had him 5th period yesterday. Let me see. I had that pulled up yesterday. I don't remember doing it, but I'm doing so many great changes. So let me check. Here, let me pause. I can't pause on share. No, it's not. I'll try to figure out what it is. Where do I get the grade? Get the grade from? I'm supposed to put in. Can I go ahead and see it engine? And do I just use the one that's at 3? Okay, so I just put that in for all 3. Well, I have another student class, and his overall was an 88. And when I look at report now, right now, 88 across the board per semester. Right. Okay. Bye. He wasn't even doing this until 2 days ago. Nobody has emailed me. Okay, so at the end, the other side, you would factor it and find the solutions. And then because of all this manipulation that you've done, you have to check your solutions. That's 2 solutions, but they may not both work, or they may not either of them work. So just it says check the solution, that means you really have checked the solution. Any questions about that, or do you need to see it? You see me work the rest of it? You want to see it work the rest of it? So this becomes x squared minus 20x plus 100 equals 32x. So then we have to subtract this. So we get x squared minus 52x plus 100. The factors of 100 are 52. The plus sign here with 2 minus. So this becomes x minus 2 equals 0. So negative 50 times negative 2 is positive 100. Negative 50 plus negative is negative 50. So then to get the solutions, you set each one equal to 0. So x is 50 and x minus 2 equals 0. So x equals 2. And then we have to check them to see if they work. So put 50 on this side, we get 50 minus 10 is 40. And 40 squared is 1600. Is that right? 40 times 40 is 16 and 2 zeros. So if we plug this back in, oh wait, no, it wasn't squared before, sorry. We had to square it to solve it. So we have 50 minus 10 is 40. And does that equal the square root of 32 times 50? I don't know what that is. Oh, that's 25, that's 264. So this is the square root of 64 times 25. Because this is 2 times 25 and 2 times 32 is 64. That's a 64. So this is 8 times 5, which is 40. So this is 40. So that one works. So if we try 2, we get x minus 2. Does that equal the square root of 32 times 2? This is x. This is 10. Sorry, backwards. X, which is 2 minus 10. So this is going to be negative 8. And this is going to be, now this, when you get this, this is all, to me, this is always weird. Because technically the square root of 64 is plus or minus 8. But when you're doing these problems, the way we do the rules is that we only use the positive half when we're solving. In this case, everything else you do and everything else I teach you in pre-cal is going to be the plus and the minus. But this isn't equal to both plus and minus anyway. So this one is not a solution. So the only solution then is the x is equal to 50. This one is your answer, not that one. Questions? I need to get to 80 or so. Okay, for the inequalities, you solve these just like you did. You solve these just like you did in Algebra 1. When it's an inequality, you have to check the answer against no, wait, yeah, this is an inequality. If you multiply or divide by a negative, you have to flip the symbol. So the first thing we're going to do here is we're going to add the 5 to the other side. So we have 2 cube root of x greater than 2. We divide by 2. So the cube root of x has to be greater than 1. What does it say? Round the decimals. Okay, a cube root can be positive or negative because it's odd. So we can have negative x values here or positive x values here. They want me to round it. we would cube both sides, which gives you x greater than 1. But it could be what do they say? What do they want the decimal? No, that's the answer. Okay, I don't know why it said this about the nearest 100. So you cube both sides. We didn't have to multiply or divide by a negative, so we didn't have to flip the symbol. For the log, in order to get the x out of the log, this is where exponentiation, which is what we talked about yesterday. When there's no base written, it's the common log, which is base 10. So we have to put a 10 here and a 10 here. So we get x is greater than or equal to 10 to the third. 10 to the third, which is 1,000. Still don't know why they're saying around the numbers. Too many pages. This one has to be factored. So you have to add the 10 to both sides. So x plus 10 less than 0. So we need 5 and 2 out of room. 2 times 5 is 10, but 2 plus 5 is 7, greater than 0. So then we have to do the two parts. So x plus 5 greater than 0, x plus 2 greater than 0. We didn't multiply or divide by a negative. So x has to be greater than -5. X has to be greater than -2. So when you look at this on a number line, 0 here, -2. 1, 2, 3, 4, 5, -5. It's greater than -5 or greater than -2. You have to choose where they, you have to choose where they overlap. So your final solution to make this work has to be the x greater than -2. If they had been going, like one going this way and one going this way, you would have an or, right, to cover both of them. But when they're going the same direction, you only choose where it overlaps. To determine if these are inverses, you have this f of g of x composition. If that is equal to g of f of x, then they're inverses. So if we take f of x, so we take f of g of x, we're going to put g inside f. So that is 6x minus 4, where the x goes, plus the 4 over 6. So the -4 plus 4 is 0, and the 6 divided by 6 is 1. So that's equal to x. So then we have to do it the other way. We have to do 6 times x plus 4 over 6 minus 4. So then this is multiplied, so the 6 is canceled, and then the +4 and the -4 are 0, so that's equal to x. When both of these things are true, then yes, these are inverses. Okay, this. I think we talked about taking this one out, although I saved it. Where did I save it? You know, I need to make a note. I think we're going to give you a formula chart so that you don't have to have these formulas memorized. This is talking about population. It quadruples. So this is how many times it quadruples in 8 years. So you have your formula. Y is equal to A, which is the initial amount, and your base here, and then it's continuous, so E, and then that's divided by the number of years. So you have an initial amount. In this case, we don't care how many there were. Your base rate is the 4, it's quadrupling. E to the raised to the E to the n, whatever power is this is the formula for continuously compounded interest. It's continually changing. It's not just happening once a month or every 2 months or whatever. So this is the formula that we would give you this in your formula chart with the E. And then it's every 8 years. So this is divided by the number of years. So if you separate this, you separate the exponent, you get A 4 to the 1/8 raised to the E, not E, T. What am I talking about? Time. So 4 to the 1/8. So this becomes 1.189 to the T. So when you're dealing with interest, remember that it's 1 plus the rate to the time. So because it's growth, if it were decay, it would be 1 minus the rate, but population on rabbits is growing. So these have been added. So that tells you that this portion right here represents your rate written as a decimal. So 0.189 is your rate, but if you want to write it as a percentage, it would be 18.9%. But I need to make a note right now so I don't forget. Formula chart, algebra 2. So that you'll have these population and interest rates and all those formulas. We'll either add it to the individual question or we'll put a formula chart on it. So you don't have to have all those different ones memorized. Okay, so these are your exponent rules. When you multiply bases, you add the exponents. When you divide bases, you subtract the exponents. When you raise a power to a power, you multiply exponents. So you need to know your exponent rules for these. Rewrite it in logarithmic form. So I have a base raised to a power is equal to a number. This is exponential form. It's this way, log base of x equals a. And then that becomes the base raised to the a power is equal to x. So the base goes here, the exponent goes there, and this is the number. So using this pattern, if we have b to the a equals x, then this becomes log base 20 of 0.0025 is equal to -2. This is your formula for this. So the same thing here, log base 49 of 343 is equal to 3/2. Okay, so 10 to the what power is equal to 0.01. Well, 0.01 is hundredths. So we know it has to be a 2 to get to 100, but then it's a decimal. So it has to be flipped over. So it has to be 1 over 100. So that is 10 to the negative 2. So this is the answer to this is negative 2. We usually do a lot of these drills out loud in class. So then 25 to the what power is 5. Well, I know that 5 squared is 25. So the square root of 25 is 5. So 25 to the 1/2 power, that's the square root, is equal to 5. Then when the base number match, the answer is just whatever is written right there. So ln is base e, so the answer is just 4. And then this is log base 10 of 100. Well, we want the bases to match. So we're going to rewrite this as log of 10 to the 2x. 10 squared is 100, and the x was already there. So now the base 10 that's implied right here and this base match. So the answer is 2x. Okay. So this is your expansion. You remember that division goes with subtraction. So this becomes log base 2 of x to the 9 minus log base 2 of 5y. When you're condensing, you go from left to right, but you can't do that as long as this number is in the front. So you have to put it back where it goes, back as the exponent first. So we have log base 7 of 2 plus log base 7 of 6 squared minus log base 7 of 9. And then we move left to right. So addition goes with multiplication. So that becomes the log base 7 of 2 times 6 squared minus the log base 7 of 9. And then subtraction is division. So your final answer, I'll write up here, log base 7. And you can leave these like this. I'm going to leave them so you know what happens. 36 times 2 is 72 over log base over 9. So then I know this is 72 over 9. 9 times 8 is 72. 36, 72, 9. So this is the log base 7 of 8. Is your final answer. You need to remember varies jointly, varies directly, and varies inversely. Varies inversely is the division. So x and y vary inversely. So I've got some other number. Okay. Oh, it doesn't matter. K over y. Yeah, you could either write it that way or you could write it this way. Because if I do the algebra, if I multiply both sides by y and divide both sides by x, those will be equivalent. So write the equation and then find it. So we know that, I'll just use this one. Negative 2 equals k over 5. So I multiply both sides times 5. K is negative 10. Then find y when x is negative 7. So y equals negative 10 over negative 7, which is 10/7. Okay, find the quotient for these. Remember that you have to factor everything, and because this is division, you're going to flip over. So you have x minus 8, x plus 8 over x plus 5. And we're going to multiply by the reciprocal, so we have 1 here. Factoring scene. Factor 1. I don't think that has a solution. Sorry, that's not a 2, that's a 3. This is a 3. This is cubed. So that is x minus, 4. 4 times 4 is 16, times 4 more 64. The cube root is 64 times same sign, opposite sign, 4 times x plus, or x plus 5 multiplied by 1 over x squared plus 4x plus 16. So this whole thing can cancel, and you're left with x minus 4 over x plus 5. Okay, you need common denominators. This one you can cross multiply here. So you can just cross multiply, and solve this one. For this one and this one, you need common denominators. So you have to multiply this side by 12 over 12, and you have to multiply this side by 4x plus 9 over 4x plus 9. So you distribute this, you get 12x minus 5 times 4x plus 9 all over 12 times 4x plus 9. So then you've got to finish it out. 20x, negative 20x minus 45, combine like terms, and then spread this out, and then see if you can simplify it after that. But finding the common denominators. So same thing here. You have an x in these two, but okay, there are 2 different ways you could do this one. I'll show you the easier way. You can do it just like that. You can multiply each term by the common denominator, which is 5x. Or in this case, you can multiply the whole thing by 5x. So when you distribute it, 5x times negative 1 over x, the x's cancel, and you get negative 5. When you distribute it, 5x and x cancel, and you get plus x. When you distribute it here, 5x times 80, the x's cancel, and 5 times 8 is 40. And then you just add the 5. So x is equal to 40. When you have a really simple common denominator, or least common multiple, depending on how you're looking at it, you can just multiply the whole equation by that, and then it simplifies really easily. Otherwise, you can do what we did here, and you multiply the missing denominator by each term, and then simplify. Okay, here we're back to your transformations. So again, the thing that we did before, if I have 2x minus 8 and I want to go down 2, that's the k value. So if I'm going to go down 2, I'm already at negative 8, that's going to become negative 10. If this one's going to reflect on the y-axis, it's already negative in front of the x. So to reflect it, you're going to reflect it back over. You're going to change this to positive. Yep. So it becomes 5x. And then a vertical stretch by a factor of 3, you just put a multiplier of 3 out front. That's your A value. 4 units to the right, followed by a reflection in x. So 4 units to the right is x minus 4. And you have to do x minus 4, and you have to do a negative 24. Because the negative and the positive inside the absolute value will be correct. So you just do both parts. Can absolute value ever be equal to a negative number? So there is no solution because the absolute value cannot equal a negative number. It always is positive. Solve, same deal here. You subtract the 6 first. So then you have your y minus 5 equals 3. And then you have to do both of them. You have to do y minus 5 equals positive 3 and y minus 5 equals negative 3. Same thing with this one. Add the 4 first and then divide by the negative and then do the 2 parts. Same thing here, but you're going to do x minus 2 is less than 1 and x minus 2. When you do the negative, you have to flip the symbol, greater than -1. And then you solve each of those. So sometimes this says graph, that means put it on the number line. So you may have a number line as part of the answer choice. Say 1 greater than or equal to +1, less than or equal to -1. Okay, this one, you're going to add the 5 to both sides. And then you divide by this negative, you have to flip the symbol over. So you're going to get absolute value of -3 minus 2x. That's absolute value. But because we're going to divide by that, so we add the 5 and we get -9. And then when we divide by the -3, we have to reverse this. So we get +9. I mean, we get -9 divided by -3, which is +3. Now you have to do both. Now you have to do -3x minus 2x less than or equal to 3, -3 minus 2x greater than or equal to -3. But you've got to do this algebra first so that it looks like this. Okay, so you've got data for one and the equation for the other, and then you're going to compare the two. Which company initially charges less? How many shirts must be ordered for the cost to be the same? So you can put this, you can do the linear regression, you can do it manually because it's linear by doing your differences, or you can put it in the regression calculator and get this equation. You can put both equations in the calculator and see which one starts out lowest and find the y value, find the x value for when they're equal. So you can do this whole thing on the calculator. So this one is asking like fit. I'm going to do this on the calculator. This is asking you, can you graph a number line? Graph on a number line. So that's okay. Okay, so we're at least 2/3 of the way done with the review. We'll finish it up next class, and then your test is done. So this is first period. So your test is Tuesday. So today is Wednesday. We'll finish the review packet next time, and then your test will be Tuesday. I will open your test. Let's see. I will open your test Saturday morning, and it will close at 9:15 on Tuesday morning. So if you're going to wait and take it Tuesday morning, in order to get your full 90 minutes, you need to walk in the door, take out your iPad and start, because it's going to close at the 90-minute time at the end of the exam time. That's because exams all over the whole district have to be the same length. But if you want to take it before then, it has a timer. It'll close at 90 minutes. So if you want to take it before Tuesday, that's fine. Just make sure you have 90 minutes to stay with it and do the test. Because, if you get up and leave or you get interrupted or you talk on the phone, the timer's still running. It's going to submit at 90 minutes because that's how much time you have. Questions? All right. That was a very long video.